Welcome to Hartman Math. This is lesson 6.3, right triangle trigonometry, part 1, where we're going to look at a right triangle from the perspective of a particular angle. So oftentimes Greek letters are used to designate angles. So this one is looks like a 0 with a slash in the middle. It's called theta, T-H-E-T-A. Theta is our angle. So we're doing everything from the perspective of that angle, and it's typically going to be one of the acute angles in the right triangle. So not the right angle, one of the other angles that are involved. So we need to know how the sides are labeled or how we describe them. So straight across the triangle from the theta, from that particular acute angle, is the opposite side. Really, we should say opposite leg. Then the one that's the leg, not the hypotenuse, the leg that is touching that angle, that's called the adjacent leg or adjacent side, ABJ. And then we've already seen across from the right angle still going to be the hypotenuse. And we're going to define our trigonometric functions in terms of these sides. And there's a mnemonic device to help you remember, which is SOHCAHTOA. It sounds a little bit like a Native American word. It is not. It's just a mnemonic device. But if that helps you remember it, that's fine. More importantly, though, you do need to be able to spell it right to use it. So, S-O over H, Ka, C, A over H, T, O over A. We're going to see what those mean because they define our three primary trigonometric functions, where we would say that the sine of theta, the abbreviation for sine is S-I-N. You've seen a calculator. You've probably seen the S-I-N button, and that does relate here. But the sine of theta is the opposite leg divided by the hypotenuse. So it is a ratio, a comparison by division of side legs. Sine is opposite over hypotenuse. Cosine, abbreviated COS, cosine of theta is the adjacent leg divided by the hypotenuse. CAH. Cosine is adjacent divided by hypotenuse. Cosine spelled this way, abbreviated COS. And lastly, T for tangent. Tangent of theta is opposite divided by adjacent. Okay? Obviously, the opposite and adjacent, if this is the angle that we're looking at, maybe this is our theta, opposite becomes this, adjacent becomes this. Hypotenuse always kind of remains constant there. And that's tangent of theta, opposite divided by adjacent. So the way that we're going to use this is today, part 1, we're going to be looking for a missing side, given the fact that we've got a right triangle. We know one of the acute angles, and we know one of the sides, and then we're looking specifically to find the side length of one of the other sides. So here's example number 1. We're going to solve for x. We're going to round our answer to approximately 2 decimal places. Here's our situation. We've got a right triangle. Here's our given acute angle, 32 degrees. This essentially is our theta. So we will need to identify which side we're trying to find and which side do we know in terms of opposite, adjacent, and hypotenuse. So go ahead and pause here for a moment. Which of those things is x? Which of those things is the 9? All right, x is opposite. Shoot across, opposite from the 32 degrees, that's the x. So opposite is in play. 9 is opposite the 90-degree angle. That's the hypotenuse. Which of our 3 trig ratios, our 3 trig functions, has opposite and hypotenuse? And that's sine. So we're going to set this up as a sine equation. Sine of 32 degrees is equal to opposite divided by hypotenuse. So that's how it sets up. Sine is opposite over hypotenuse. We now just solve for x once we have that set up. So it says x divided by 9. We want to get x by itself. We want to undo divided by 9. We're going to multiply both sides by 9. That would essentially cancel out here. We have x is equal to 9 times the sine of 32 degrees. That would be the exact answer, but our directions are to round this to 2 decimal places. So take out your calculator. Make sure before anything that it's in degree mode. So it'll either say DEG or D. If it says RAD or R, that means radians. That's a different kind of an angle measure. You need to change your calculator into degrees. Once you do that, you should be able to type it in just like this. 9 sine 32, hit equals, round to 2 decimal places. You should get the x's approximately. That's what the wave equal sign represents. X is approximately 4.77. All right, your turn. Go ahead and pause here until you work through. Solve for x, round to 2 decimal places. Which function are we setting up? Again, here's our 41 degrees. We've got opposite. We've got hypotenuse. It's a sine problem again. So we're going to say sine of 41 degrees equals x, the opposite, over 11.8, the hypotenuse. We're going to solve for x, so we're going to undo the divide by 11.8. We're going to multiply both sides by 11.8. Cancels out. Type that into your calculator, 11.8 sine of 41. Make sure your calculator's still in degree mode. If it was before, it should still be now. Hit equals, and get x is about 7.22. All right, example number 2, solve for x, round to 2 decimal places. Pause here as you think through. What side is x in the right triangle? What side is the 36? What would that mean as far as which trig function we should use? X is opposite. The 36 is not the hypotenuse. It is one of the legs that's touching the 48 degrees, and that makes it adjacent. We've got trying to find opposite. We know adjacent. O and A, that means tangent. Tangent of 48 degrees is equal to opposite over divided by adjacent of 36. Solving for x, undo the divide by 36. Let's multiply both sides by 36. We get 36 times the tangent of 48 degrees is equal to x. Let's use the calculator at this point. Type that in. X is about 39.98. Your turn. Pause here. Solve for x. All right, so hopefully use the cosine function, because this time we don't have the opposite. Not trying to find it, don't know it, don't care about it. We have the adjacent, the leg that's touching the 63 degrees. We also have the opposite of the right angle, the hypotenuse. Adjacent and hypotenuse means where you're going to use cosine. Cosine of 63 degrees is adjacent x over hypotenuse 11.11. Multiply both sides by 11.11. Type that into a calculator. You should get x is approximately 5.04. Example number 3. Solve for x. Round to 2 decimal places. Once again, same kind of format. Pause as you think about it. We've got a 77-degree angle. That's our theta. In reference to that angle, what are the 26 and the x? What sides do they represent? And what function does that mean that we should use to set up our equation? 26 is the opposite. X is across from the right angle, so that's hypotenuse. Opposite, hypotenuse, O and H means sine. So katoa, sine of 77 degrees is 26 over x. So it's a little bit different in the way the equation is set up, being that our variable is on the bottom. So we're going to approach it the same way. It's going to take a little bit longer to solve this equation, though, because we're going to undo the divide by x. How do we undo dividing by x? We should multiply both sides by x. X's would then cancel. We would get x times the sine of 77 degrees is equal to 26. Still got to go further because now we're trying to get x by itself. So how do we undo the sine of 77 degrees? Well, since this was multiplication here, we should divide both sides by the sine of 77 degrees. And we can divide by the sine of 77 degrees because the sine of that particular angle is a number. So we can divide both sides by that number. We're going to divide both sides by the sine of 77 degrees. Type that in on your calculator and you get x is approximately 26.68. It's your turn, so pause here as you solve for x. We're going to use the tangent function, set up a tangent equation because opposite of the 34 degrees is the known 7.2, while the unknown x is adjacent. Don't know the hypotenuse, don't care about the hypotenuse for this problem. So O and A means tangent. Tangent of 34 degrees is 7.2 opposite divided by x, the adjacent. We're going to undo the divide by x. We're going to multiply both sides by x. And since this is multiplying by the tangent of 34 degrees and we're trying to get x by itself, we're going to divide both sides by the tangent of 34 degrees. And that means it's calculator time. Type in 7.2 divided by the tangent of 34. It should be in degree mode. And that's going to say that x is approximately 10.67. All right, our final example, example number 4, says that according to the Health and Safety Authority, an extension ladder should make a 75-degree angle with the ground. How high up the wall would a 25-foot ladder reach? Round to 1 decimal place. Sketch it. Label everything that you know we're trying to find in your sketch. Pause here as you sketch it. Label your sketch. Figure out if it's going to be a sine, cosine, or tangent equation. Solve, round appropriately, label, then hit play when you're ready. All right, our sketch, and it should be a right triangle. We're doing right triangle trigonometry. Should look something like this. 75-degree angle with the ladder and the ground. Unknown height. You might have put x, that's fine. Right angle here. 25 feet is the length of the ladder, and that's on the diagonal, which really means for our purposes opposite the right angle. That's the hypotenuse. So this is a sine equation because opposite of the 75 degrees is the unknown height. 25 feet is the known hypotenuse. So that's the sine function. Sine of 75 degrees is h over 25. We're going to multiply both sides by 25. So H will be 25 times the sine of 75 degrees. We're going to type that in. Don't have to worry about the degrees. 25 sine 75, hit equals. We're going to round to 1 decimal place, and we're going to label our answer, and it's going to come out to be 24.1 feet. Approximately is how high up the wall it will touch. That's it for today. I'll see you next time.